All right, let's jump right in. We usually think about a system's design as something, well, separate from the system itself, right? It's a blueprint, a diagram, something you look at, but you don't run. And that separation, that's where a huge problem in software really begins. So, I want you to think about this for a second. What's actually the hardest part of software? Is it building the thing from scratch? Or is it changing it later on? Because, let's be real, most of a system's life is spent being changed, not being built. And the real cost, the real friction, well, that comes when you're trying to modify a system where the blueprints and the actual code have gone their separate ways. Yeah, this disconnect has a name. Experts call it the semantic gap. And really, it's just the space between what the business folks think the system does and what the code actually does. And the wider that gap gets, oh man, the harder and, frankly, the more dangerous it becomes to make any changes at all. But what if we could close that gap? What if the model, the blueprint, wasn't just some static picture in a document somewhere? What if it was a living, breathing, executable part of the system itself? That's the huge idea we're going to dig into. Okay, to really get our heads around this, we're not going to start with some super complex abstract theory. Nope. We're going to start with something that looks, well, deceptively simple. Almost trivial, you might think. This right here, this quote captures a really profound shift in thinking, the idea that properties can be executable. So what does that even mean? It means an object's properties don't just have to be containers for data. They can actually hold behavior. They can hold the logic that defines what that data is and how you're supposed to use it. And just look at this plain JavaScript object. The key here is just how simple it is. There's no complex classes, no inheritance, none of that. It's just a simple object that doesn't just hold data about a string. No, it holds the actual executable logic for how to handle it, how to format it, how to parse it. It's not just passive data anymore. It's data that has its own intelligence baked right in. Okay, so let's see where this is going. Because that little object we just looked at, that's actually the first step in pushing back against a really common and really problematic pattern you see in a lot of software design. And that pattern is called the anemic domain model. It's a bit of a mouthful, but the idea is simple. It's when your objects are just these dumb bags of data. They're totally passive. They just sit there waiting for some other service or manager class to come along and do something to them. And what happens? Your business logic gets smeared all over the system, making everything fragile and a total mess to understand. And this slide just lays it out perfectly. On one side, you've got the anemic model. Logic is totally separate from the data. But on the other, you have a behaviorally complete model where the object actually knows its own rules. That little value types object we saw, that's a behaviorally complete model. It knows how to format itself. It knows how to parse itself. It's a small change, but it's a super powerful example of pushing the rules right down onto the data itself. All right, let's peel back another layer here. Because this whole idea, it's not just some clever little coding trick. It actually has its roots in some really formal, really rigorous modeling theories that are all about achieving ultimate clarity and precision. So what does that mean in practice? Well, it means the model stops being a helpful suggestion and starts being the system's law. It's like its constitution. This conceptual schema isn't some diagram you glance at. It is the set of absolute, unambiguous laws that the system runs on. It literally governs the entire universe of your application. And the great thing is, you can actually build this master plan systematically. There are methodologies for this, like fact-oriented modeling, that give you a clear process. You start with simple things, real-world examples that everyone understands, and then you just step by step add the rules and constraints that define the reality of your system. And this is where the model really gets its teeth. These constraints, they're not just suggestions. They become the fundamental laws of the system. So, for example, a rule that says an order must have a customer, that's not just some check in the user interface anymore. It's a law enforced by the model itself that makes it literally impossible for invalid data to even exist in the first place. Okay, so we have this super solid foundation, right? We've got executable objects and a model that acts as law. So what kind of architecture can you actually build on top of that? Let's zoom out and take a look. Well, for one, you can build systems using something called event sourcing. Now, instead of just saving the current state of an object, think about this. You save every single thing that has ever happened to it as a list of events. You're not just saving a snapshot in time, you are saving the entire unabridged history. And once you're doing that, it opens the door to really powerful patterns like CQRS. It lets you completely separate how you write data, which is now super simple, you're just adding a new event to the list, from how you read data. You can create all these different highly optimized views of the data for whatever you need, and all of them are built from that one single source of truth, the event law. Your core objects can also become incredibly flexible. There's this thing called the role object pattern. So a person object can, at runtime, dynamically put on the hat of a customer or an employee. It gains new abilities and properties on the fly, without having to be this one giant bloated object that knows how to do everything from the very beginning. Okay, let's tie all of this together now, because this is where you really see the ultimate payoff of thinking this way. The system truly becomes a living blueprint. You can literally reconstruct the state of your entire application at any point in time just by replaying that log of events. Think about that. The history, the commands, the definitions, that is the system. And here's the kicker. A language like JavaScript stops being just the thing you use to build the application. It becomes the language you use to build the model itself. The code you write is the design. Your system schema is now a live, executable thing. So that really leaves us with this final big question. If your model could be a living, executable history of itself, just imagine what kind of systems you could build. When that line between the blueprint and the building just dissolves, you're not just making software that's easier to change. You're building systems that are designed from their very DNA to evolve.